Combinational circuit part 3, decoder and encoder circuit. Decoder, the basic function of a decoder is to detect the presence of a specified combination of bits on its input and to indicate that presence by a specified output level. It has n number of inputs and 2 to the power of n number of output lines. One of the output will be active high based on the combination of the inputs present when the decoder is in enable mode. So the output of the decoder are nothing but the mean terms of n input variables lines when it is enabled. The 2 to 4, 3 to 8 and 4 to 16 decoders are shown in figure below. Now design the 2 to 4 decoder. As earlier says that 2 to 4 means the two number of inputs, that is called A1 and A0, and the 4 number of outputs, that is 2 to the power of 2. So Y3, Y2, Y1 and Y0 are the 4 number of outputs. A0 and A1 are the 2 inputs and E is the enable line. When E is equal to 0, then the decoder will be deactivated. So irrespective of the inputs A0 and A1, so Y0, Y1, Y2, Y3 will be 0. So now if E is equal to 1, then depending upon the combination of A0 and A1, the Y0, Y1, Y2, Y3 will be high as 1. So now if A0 and A1 equal to 0, 0, that means 0th port, that is called Y0 will be 1. 0, 1, 0, 1, so that means the first port, so that is called the Y1. So Y1 will be 1. 1, 0, that means the Y2. 1, 0, that means 2, that means the Y2 will be 1, and 1, 1, that means the 3, so the Y3 will be logic 1. So now from this truth table we will get the expression as Y3, that means the A1 1 and A0 1 and E1, so E, A1, A0. For Y2, Y2 means E, A1, A0 bar. Y1 means that is E, A1 bar and A0, and the Y0 means that is 0, 0, that means E, A1 bar, A0 bar, E, A1 bar, A0 bar. So now according to the mean terms we will make the circuit. This is an 4 AND gates. The inputs are the E, A1, A0 for Y3, E, A1, A0 bar for Y2, A1 bar, A0, E for Y1, and E, A1 bar, A0 bar for Y0. So now therefore the outputs of the 2 to 4 decoder are nothing but the mean terms of the two input variables A0 and A1. So E is the equal to 1. If enable E 0, then all the outputs of the decoder will be at 0. For the 3 to 8 decoder, here we consider primarily that the enable input is 1, so the device is enabled, so we are not considering the E. So now only the 3 inputs ABC and the outputs will be the 2 to the power of 3, that means 8. So D0 to D7, the 8 number of outputs. So depending upon the combination of 0, 0, 0, then D0 will be 1, 0, 0, 1, D1 will be 1, that is 0, 1, 0, the 2 will be 1, 3 will be 1, 4 will be 1, according to the 1, 1, 1, then the D7 will be 1. So from here we will get D0 is equal to A bar, B bar, C bar, D1 is equal to A bar, B bar, C, D2 will be A bar, B, C bar, and so on. The D7 is ABC. And according to that, the circuit of the AND plane, there is so many AND gates are there. So for the D0, A bar, B bar, C bar will be connected. D1, A bar, B bar, C will be connected. D2, A bar, B, C bar will be connected. From this truth table, we will get this expression and we will make the circuit like this. Implementation of higher order decoder using the lower order decoder. The 3 to 8 decoder using 2 to 4 decoder. Now we know that the 2 to 4 decoder has the two inputs A1 and A0, and the outputs are the Y0, Y1, Y2, Y3. So 4. Whereas the 3 to 8 decoders, that is A2, A1 and A0, and the 8 outputs Y7 to Y0. So we can find the number of lower order decoders required for implementing the higher order using the following common formula, that is the M2 by M1, where M1 is the number of outputs of the lower order decoder and M2 is the number of outputs of the higher order decoder. Here the higher order decoder is 3 to 8 decoder, so output is 8, so M2 is 8 and M1 is 4. So now the required 2 to 4 decoder is 8 by 4, that is equal to 2. So two numbers of 2 to 4 decoder needed. So now 2 to 4 decoder have the two inputs A0 and A1. So the third input will be considered as the enable line. So now if A2 is connected to the enable, then from the truth table we will get when A2 is 0. A2 is 0. This is the active high enable circuit, the 2 to 4 decoder. So if E is 1, then the upper decoder will be on, and if E is 0, then the lower order decoder will be on due to this NOT gate. So if A2 is 0, then this upper order decoder will be deactivated and lower order decoder will be activated. So now depending upon the combination of A0 and A1, if A1 is 0, 0 and A2 is 0, so then the lower order decoder will be activated. So then we will get for A1 A0 0 0 we will get Y0, 0 1 Y1, 1 0 Y2 and 1 1 Y3. Now for A2 is 1, then the upper order decoder will be turned on, lower order decoder will be turned off. So now depending upon the combination of A0 and A1, at 0 0 then we will get the Y4, 0 1 Y5, 1 0 Y6 and 1 1 Y7. So now from this truth table we will make the device as the 3 to 8 decoder using the 2 to 4 decoder. So in this video lecture today, this 3 to 8 decoder, up to the 3 to 8 decoder using 2 to 4 decoder is described. In the next video we will carry on the lecture.